The purposes are to compare Excel output and SAS output and to know the locations of A, B, S, E, R square. No, not R2, R square, and names of dependent and independent variables, yeah, and interpretation of A, B, and R square. You can reach. The following are the midterm and final exam scores for 10 students enrolled in an elementary statistics course. Perform an appropriate statistical method on these data to see how well you might be able to predict a student's final exam score. So final exam score is the predicted variable y from a knowledge of students' midterm score. Therefore, knowledge of midterm score x is the predictor or independent variable. Exact and SAS outputs are given below. Compare the locations. So here R square is here, S sub E is here, N is here, and you skip the middle table, ANOVA table, yeah, and go to the last table, coefficients table, intercept A, this is mid, this is X midterm score shortening, B value is here. So y hat estimated final score is equal to A plus B times X. In SAS output, what can you find? Dependent variable final, here N, this is Y, here N, you see, and ANOVA table, you study later. Square root of MSE, MS is this one, MS error E, okay, this is MSE. If you take square root, then you get square root of MSE 3.07 something. This is called S sub E. No, this one. S sub E is standard error of estimate is square root of MSE. Okay, for the time being, note this parameter estimate here, intercept y-intercept A, and B is here, midterm X is here. So here the same, A in Excel, A in SAS output, B in Excel, B in SAS output, and here R square in SAS output, and R square in Excel, here S sub E 3.07 something, and S sub E 3.07 something, yeah, that's it. Problem 1. A university lecturer in statistics wants to emphasize to students the value of study to exam performance. That means if they study more, their exam performance will be better. Yeah, you can guess this. The lecturer monitors the amount of time in minutes. So in minutes, ratio level measurement. Amount of time, this is 1 by x1. Yeah, and all 11 students, it seems this is number of cases, sample size n in the class spent in the library per week, and the final scores for each student. The data are recorded in the following table: exam score, final score. Two regression outputs are given below. Choose the correct output to answer the following questions. So it seems that exam score is y, library time is x, scores are interval level measurement, yeah, interval level, and time in minutes is ratio level. Yeah. Okay, it seems that according to this one, yeah, the value of study time to exam score, that means study time affect exam score. This way of view. In this way of view, exam performance is y score. And if you check the questions also to make sure. You want to estimate score, therefore score is y. Therefore library time is x. Here x. Okay, that's correct. So check to answer the following questions. Estimate the score of a student who spends 1 hour. 1 hour. So this is x value. X is 1. But in computation, x is minutes. 1 unit is 1 minute. Therefore, if you enter the value in x, you must enter 60 minutes, not 1 hour. Okay, now y hat is equal to estimated score is 35y something, plus here you copy this one, a plus b. B is here 0.47961 times here x is 60. You compute like this, a plus b times 60 equal to, then right here the answer is you can check the answer here, 74.7. Interpret y-intercept. So this is the meaning of, this is the y hat is a plus bx. Y hat is a plus bx. A is the y-intercept. So you recall mathematics. So this is suppose y hat, estimated y value. This is x. Then this is the equation, y hat is equal to a plus bx. Then b is the slope. B is slope. Here 1, here b, and this is a. So what is your interpretation? If x is 0, if x is 0, then y hat is a units, right? Units. So in this problem, you write if the studying time in library is 0 minutes, or you can write if a student does not study at all in the library, then her or his estimated exam score will be, or his or her exam score is estimated to be a 35.88 marks. You can say like this. Here. So check if correct or not. Another page here. If a student spends 0 minutes in the library, his or her exam score would be 35.9 marks, like this. So here you compute it. Here explain. Here you can understand. Here delta y means increase in y. Delta x means increase in x. Okay, let's go back. Interpret the slope. Y-intercept a in slope b. What is the slope? So here, if this is 1, slope is b. So you can say if x increases by 1 unit, then the estimated y will increase by b units. This is sure. If you move from this point to that point, you increase x by 1 unit and you increase y by b units. This is the interpretation of slope. So for this problem, how do you write? Let's see. If x, if the study time in library increases by 1 unit, 1 minute, or you can say for every 1 unit study time in the library, the estimated score, exam score is how many minutes, how many marks? 0.5, 0.48 marks. The estimate score will increase by the estimated exam score will increase by 0.47 marks. So for every minute you can expect 0.48 marks 0.48 max, more and more. Yeah, this is the meaning. So you write correctly and simple. Example writings here. Each additional, actually for each additional 1 unit, no increase, you don't need increase, additional means increase already. For each additional minute in library time, for each additional minute in library study time, the exam score is expected to increase by 0.48 marks. Yeah, these two are important, yeah, because they are interpretations. You must write carefully. Explanations here, okay. Yeah, clearly if you put here 5, so you multiply by 5. If you put here 6, multiply by 6, the difference will be, the difference of y will be 0.48, yeah? 0.48 more here, 0.48 more, 0.48 more, 0.48 more. If you increase x by 1 minute, 1 minute, 1 minute, this is clear. Interpretation of R square. So later you will know what R square is. For the time being, just note R square is SS R divided by SSD. For the time being, note this. So R square is, what is R square? 0.805 806, yeah, 0.806 square root of, this is the incorrect one, yeah, output incorrect, because why? You can check, observation 11 is correct, but here exam score is, here you must put, the output must contain x, but you see here y, yeah? Therefore you don't use this output A1 first output, and A2 is the correct output, yeah, n is correct. Here you see library time is correct, you know, so all are correct. So you use this R square. R square is 0.806. This is equal to 8060. Yeah, this is 80.60 by 100. That is the meaning. And R square means SLR. R square is SSR divided by SST. SSR is this one. SSR model. Yeah? Model means regression. SSR is this one, 1948 point something. SST total is this one. So if you divide this by that, you get R square. Okay, this is SSR is the error removed. Yeah, if you use this regression equation, and total error is 2418. Yeah, the error removed is 1948. So if you take ratio, this is R square. If you change to percentage form, 80.6%. So 80.6% of error in X, yeah, error of estimate in Y is removed by the regression equation or explained by regression equation. Okay, you know this one. Yeah? The regression equation, yeah, model explain means removed. Yeah, 80.6% of total variation in exam score. That is, if you use this equation, yeah, if you use this equation to estimate exam score for 40 minutes, you will get some number. Yeah? Y score, exact score is 50, your Y hat score will be a little different from 50. Yeah? If you enter 30 and 8, Y hat will be a little different from 45, yeah? 45 and so on. If you collect all these different squares, if you add them all, this is the total error. Yeah? Total error is this one, yeah, regression 1948. This is error 469. This error will occur if you use this equation to estimate for each x. Then the total square difference between y hat and actual y values is 469 units. This is the meaning. So this error will remain. If you don't use the regression model, you will use y hat for each estimate the same. If you use y hat for each estimate, then your error will be square total error will be 2400. If you use the equation, your error will be only 469. So the rest 1948 is removed by your regression equation. This is about 80%. If you don't use the equation, you make your mistake will be 100 units. If you use the equation, your mistake will be only 20 units. Therefore 80% is removed. This is the meaning. Why are y values different from each other? Why are the exam scores of students different? You can say because they study different times. Their amount of study time are different. Maybe other factors also. Some are smart, some are weak. Okay, there are other factors also, but 80% of difference is due to their study time difference. This is the meaning. This is the meaning of explaining. 80% is because of study time difference. 20% depends upon other factors. Maybe some are smart, some are weak. Maybe some have good background in knowledge of English and math. Some have weak background, some have good background. Other things occur. 20%. But study time decides 80% of success. This is the meaning.